In getting the derivatives of logarithmic functions, we are going to use these three rules. That is, the logarithm of x to the base a with respect to x is equal to 1 over x times ln of a. Take note that this x here must be any real number greater than 0. So we are referring to all positive numbers. However, if we are going to get the derivative of ln of x, it will become 1 over x. Why? Because it is understood that ln of e is simply 1. That is already understood. Okay, so that is initially 1 over x times ln of e, because ln of x definitely is a base e logarithm. And because ln of e is simply 1, it will become 1 over x here. On the third rule, the derivative of ln of the absolute value of x is equal to 1 over x. Now in this case, x should not be 0. So you can have, since that is absolute value, you can have negative numbers. Now these three rules will be applied in solving for the derivatives of logarithmic functions. So you just need to observe the base a and the variable x here. On the first example, the derivative of 4 times logarithm of x to the base 7. We see here that there is 4 and 4 is constant. So we are going to use the rule of constant, okay? Constant multiple theorem. So we factor out and we bring out 4 and we're going to get the derivative of logarithm of x to the base e. The base is 7, so there you go, a is equal to 7, so we have 1 over x ln of 7. Then we multiply 4 to 1, so that will be 4 over x times ln of 7. Now to get the second example here, so we have the derivative of 3 times ln of x. We separate 3 and get the derivative of ln of x, so that is 1 over x. Multiply 3 to 1 over x, so we have 3 over x. On the third example, the logarithm of x to the base 3, then simply get the base 3, so that will be 1 over x times ln of 3. Well, we just keep on repeating x here because we're just referring to the basic rule of differentiation. However, when we proceed to more complicated, then you're going to meet the other rules. On our next example, we're going to solve this. The derivative of logarithm of x to the base 1/2 is equal to 1 over x times ln of 1/2. Take note that ln of x over y in the rule is equal to ln of x minus ln of y. That is the rule of quotient in logarithm. So we can actually express it ln of 1/2 into x times ln of 1 minus ln of 2 to follow the rule. And since ln of 1 is simply 0, so we have 1 over x times 0 minus ln of 2. And that will become 1 over x times negative ln of 2. So our final answer is negative 1 over x ln of 2. On our next example, that is the product of ln of x and logarithm of x to the base 9. Take note that is a product, so we're going to use the product rule. We get the derivative of ln of x, and that is 1/2. The derivative of logarithm of x to the base 9 is 1 over x ln of 9. So using the product rule, that is getting now the derivative of ln of x is 1 over x, multiply it on the second factor, logarithm of x to the base 9, plus, so take note plus when we're referring to product rule, and the derivative of the second factor is equal to 1 over x ln of 9 times the first factor ln of x. So we now have logarithm of x to the base 9 over x, so we just multiply plus ln of x over x ln of 9. So that is already accepted. So we have the next example. The derivative of ln of the absolute value of 3x is equal to, remember that ln of 3x is actually the product of ln of 3. Okay, that is a product of ln of 3 or 3 and x, product of 3 and x. So we can expand it from product to gagamitin natin ang multiplication. It will now be the derivative of ln of 3 plus ln of the absolute value of x. So that will now make use of the sum rule in derivative. Okay, so plus the derivative of ln of the absolute value of x. Okay, the derivative, this ln of 3 is actually constant, and that will become 0. And the derivative of ln of the absolute value of x is 1 over x. So the answer is 1 over x. The next example makes use of the product rule. So the derivative of logarithm of x is 1 over x ln of 10, because that is a common logarithm, so the base is 10. And the derivative of the logarithm of x to the base 7 is 1 over x ln of 7. So we get the derivative of the first factor logarithm of x, and that is equal to 1 over x ln of 10. Multiply it on the second factor, that is logarithm of x to the base 7. Add, get the derivative of the second factor, logarithm of x to the base 7, that is 1 over x ln of 7, and then multiply it on the first factor, that is logarithm of x. So take note that in this rule, when you get the derivative of the first factor, dapat i-multiply mo siya sa second factor. Okay? And then, pagkatapos mo ginawa ang derivative ng first factor, sa second factor ka naman. Anyway, that is addition. So, kahit anong mauna in the derivative process. Okay? And do not forget to multiply that to the factor. So, laging partner first and second, second, first, like that. Okay? And this will now be equal to logarithm of x to the base 7 over x times ln of 10 plus logarithm of x over x times ln of 7. So this is already accepted as your final answer. On the next example, that is the derivative of ln of x over logarithm of x makes use of the quotient rule. So that will now be, so we first get the derivative of logarithm of x, and that is 1 over x ln of 10. The derivative of ln of x is 1 over x. Okay, now in the rule of quotient, we are going to square the denominator. Then we get the derivative of ln of x, the numerator, which is 1 over x, and then multiply that to the denominator, which is logarithm of x. Take note, the operation is subtraction. Now get the derivative of the denominator, and that is 1 over x ln of 10, and multiply that to the numerator, ln of x. Now we have logarithm of x over x minus ln of x over x ln of 10 over logarithm of x, the quantity squared. Okay, now we continue. So we now have the LCD for the numerator here is x over, or x ln of 10. Now multiply x ln of 10 to the entire numerator. Now we have ln of 10 times logarithm of x minus ln of x over the logarithm of x squared. So we now have, we can simply bring down x ln of 10 and make it partner, o itabi natin siya sa logarithm of x squared. So kung ano itong numerator on top, yung buong numerator na ito ay ilalagay natin dito. So we have ln of 10 times logarithm of x minus ln of x. Okay, so that is the derivative. So on this example, we are going to use the product rule. Remember that x logarithm of x to the base 4 is actually the product of x and the logarithm of x to the base 4. Therefore, we're going to get the derivative of x, and that is simply 1, and get the derivative of the second factor, that is logarithm of x to the base 4, which is 1 over x ln of 4. Now use the rule of product, so we get the derivative of the first factor x, that is 1, multiply it to the second factor logarithm of x to the base 4, plus, now get the derivative of the second factor logarithm of x to the base 4, and that is 1 over x ln of 4, and multiply that to the first factor, which is x. We combine or simplify, so we have logarithm of x to the base 4 plus x over x ln of 4. Then we can now cancel x here, so our final answer will become logarithm of x to the base 4 plus 1 over ln of 4. You might as well want to rewrite that, have a common denominator, which is ln of 4. So your answer may be in this way. So we have ln of 4. It can be written this way. So logarithm of x to the base 4 plus 1 over ln of 4. But this is already accepted. On this example, this is again the product rule. So we get x squared, and the derivative of x squared is 2x using the power rule. And the derivative of the second factor makes use of the logarithm rule, and that is 1 over x ln of 1/3. And take note that ln of 1/3 can be rewritten, and that can be 1 over x times ln of 1 minus ln of 3 following the quotient rule for logarithm, and that will be negative 1 over x ln of 3, because ln of 1 is simply 0 in the rule. Now we're ready to write that using the quotient rule. We get the first factor x squared and get the derivative, which is 2x. Now multiply the derivative to the second factor logarithm of x base 1/3. Since that is product, the operation is addition. Okay, that is associated already on the product rule. Now we're getting the derivative of the second factor, that is negative 1 over x ln of 3, and multiply that to the first factor, which is x squared. Now we combine, so we have 2x times logarithm of x to the base 1/3 minus, okay, here we can observe that x squared and x, they have common variable, common factor x. So this will now be x, and that will be minus x over ln of 3. So we're writing that again, so we have 2x times logarithm of x to the base 1/3 minus x over ln of 3. So it matters that you need to really recall the different rules of logarithm, and with these rules, you play with these rules and be able to simplify with the use of these rules. So logarithm rules are really essential in this case. Remember again that when we are evaluating derivatives, let's say for example we have f of x is equal to the logarithm of x to the base 4, and then you're asked to get what is f prime of 2. So if the question is like that, and you see that the notation is f prime, so it simply tells you that you need to first get the derivative of the function f. Now use the rule of logarithm, and that will be 1 over x times ln of the base, and the base here is 4, so ln of 4. Now after getting the derivative of that, you're ready for the substitution. So substitute x, let it be 2, So we have 1 over 2 ln of 4. So this is your exact answer. Another example, if you have g of x is equal to, let's say, ln of x, let's say that's 3 ln of x, and you're going to solve what is g prime of 1. Okay, so here, get the derivative of g of x first. So we have g prime of x is simply equal to 3 times, since you have to separate 3 using the constant multiple rule, and now get the derivative of ln of x, which is 1 over x. So that will be 3 over x. Now, after getting that derivative, that is 3 over x, you are now ready for the substitution. Let x be equal to 1, so we have 3 over 1. So the answer is 3. So just take note that when you're solving for f prime of 2 or whatever is that x, you first need to get the derivative of the given and then substitute the given value of x to the derivative, and you can now have the value needed.